안녕하세요. 저는 세라입니다. 한국 조금밖에. So I will speak in English. Yeah. But thanks for coming for the presentation today. Nice to meet all of you. My name is Sarah. I am a developer advocate for the Filecoin virtual machine team as part of Protocol Labs. My focus is on developer experience. So if you are a developer, we are very much focused on how you experience the FVM and how we can help you, because we are still developing it and we are releasing it every single week with a new development. So there's a lot of information to explain, and that is my team's job. So today I will be sharing with you about what the FVM is. Some of you might know a little bit about it already. I'll share also what it can do today and what we plan to release in the coming months. And thank you so much for TVCC for hosting me here today. Okay. So today I will run through a few things. I will give an introduction, followed by an idea of what the FVM is, and then the roadmap of delivery, because I mentioned that we are still delivering and we will be launching next year in Q1 2023. And also what the FVM can do for different solutions. So what are different solutions that you can think of, and a few key scenarios that we have been focusing on. And lastly, I'll do a short demo to show you how an MVP of it can work today. Okay, so I will share about the Filecoin master plan. So for those of you who are new to Filecoin or you have heard about it, you may or may not have seen this master plan. This is what we have been building in the past 4 to 5 years that Protocol Labs and Filecoin has been building on, so the storage network, and why we are only building for compute over data today. So we started with step 1, where we wanted to build a very strong storage network, storage layer. So that is the Filecoin itself. And so you are able to transfer large amounts of data and store it with a whole bunch of storage providers that are helping to create this network. So as of today, we have about 280 petabytes of data committed storage on the network. And that translates, 1 petabyte is about 1,000 terabytes. So that's a lot of hard drives, to give you a sense. And so on step 2, what we want to do is to onboard data, so useful data, onto this committed storage. So we have a lot of, we're looking for data sets that we want to put onto all these committed storage so that we have useful data within our storage network to then build applications and solutions upon. So now we are at step 3, and that's what my team is building. We want to be able to provide programmability to the network and to the storage on it. What the Filecoin virtual machine can do is to compute over state, so the metadata of your storage. And then I will share about how we will then compute the data itself later on. Okay, so now the FVM itself delivers on-chain programmability to the Filecoin network, and I mentioned a little bit earlier on about how that is different from computing on the data itself. So you're computing on the metadata of the storage on the network. This is a little bit different from, let's say, EVM. So if you've heard of smart contracts on EVM, it's slightly different. So for Ethereum EVM smart contracts, what it does is to then write to storage, which is very expensive. So if you were to create a decentralized app or a dApp, you would have extra costs to write to the storage to access that, to let your dApp run. Whereas now, we propose that you then compute on the metadata, so you can manage the storage around, and only when you need to access the storage, that's when you use a layer 2 solution to access and compute the data itself. And so you should have a much more performant and a cheaper solution when you build your dApps. So that is what the FVM's idea and motivation is. Yeah, and one point to add is that we are not looking to compete with EVM. We are looking to complement. So it's a supporting tool to be able to interact with the EVM and other blockchains out there. Okay, so I talked a little bit about layer 0s, layer 1s, and layer 2s. To make it very clear, this is where FVM will sit. So layer 0 will be the Filecoin storage network, which is where all your data is stored by storage providers. FVM sits on the layer 1 on top of that. When we launch it to mainnet, it should be seamlessly part of the network itself. And so if you were to build on the network, you should be able to access the FVM without having to additionally work in a different environment. And then you have layer 2 solutions on top of that. So once you can compute on metadata, you can build any almost anything you can imagine for layer 2 solutions. So I'll run through some scenarios later on, but you can think of things like computing over data, time-locked retrievals, data DAOs. These are all the layer 2 solutions that you can build on top of a very strong layer 0 and layer 1. Okay, so I talked a little bit about examples. I'll let you have a look at this slide. There are many, many different scenarios that you can think of. You can think about like trustless reputation systems. So if you want to have an FVM that is able to determine, let's say, a storage provider or a client, what their behavior is and whether that has been consistent and it is the kind of behavior that you want in the ecosystem, you can then have the FVM to certify, for example, that this is a trusted client or trusted provider, and you can continue to work with them so you don't have to go through much more computation to verify whether they are trustworthy or not. So that could reduce a lot of the workload and it can automate a lot of things. So that's just one example. Yep. And there are a few other things you can automate as well. So especially for storage, because that's what we focus on. If you have a storage deal, you can have replication workers and repair workers. So you can ensure that your storage is perpetually stored. I wouldn't say it's permanent storage, but it's like perpetual storage, and you can automate that. So if your deal is expiring, you wouldn't have to manually remember to go and renew that deal. You can have an automation with FVM to renew the deal based on the criteria that you have set. Okay, to give an idea of where we came up with the FVM, we were very inspired by hypervisors, actors, and Unix kernels. You can think of hypervisor as like we wanted a system that could support many different runtimes, multiple runtimes at once, and be a seamless connector across different blockchains. So the hypervisor model and, for example, the actor model that makes it a primitive is something that we really were inspired by, and that is kind of the concept behind how we built the FVM. And so now I will run through the architecture for the FVM. This is quite a heavy slide, so I will go through point by point and then take you through the model itself. Yeah. So I'll start over here. So there are a few reasons I think these are certain characteristics of the FVM, and I'll talk about the reasons why we chose to use it. So for example, we wanted really high performance. We actually built it with WASM. WASM is one of the main execution languages that we use within the FVM itself. The reason why we use it is that it accommodates for many different high-level languages. So when you build your smart contracts, or we call them actors in the FVM, you will be able to use a whole different kinds of languages that you are comfortable with. So if you want to use like Python, JavaScript, Rust and C are recommended languages for this, but you can use these languages to then build your smart contracts or actors to then use on the FVM. Yep. And for these 2 points, we built it such that it's able to support multiple runtimes. So it's a highly performant virtual machine. And we've also built it to have really low-level system calls to allow you to have more control from your contracts calling into the system itself. And then how many of you have heard of IPLD? Hi. Okay, so to explain briefly, IPLD is something that Protocol Labs has invented. It is a hash-linked content structure. So we have addressable content, which means that every piece of content will have a CID given to it. And we use the IPLD data structures to be able to connect these different content chunks. So when it comes to cryptography, it actually allows for much more security if you build it with IPLD. Cryptographic hashes. So if you have a hash, then you can, it's a way of cryptography to make sure that you encrypt and decrypt the CIDs, the CIDs of different content chunks to ensure that they're part of the same data structure before you can verify that, okay, this is one piece of content that we put together. So that is how IPLD is meant to work. Yeah, so that's, we are IPLD native within the FVM and also, within the FVM itself. And then we'll come over to how we support many different foreign accounts. So as I mentioned earlier on, we are not here to compete with different blockchains or different smart contracts. We want to complement them. And so what we need to be able to do with the FVM is to allow for a seamless experience. So if let's say you're an EVM developer, you shouldn't have to use different tools. And I'll show you a demo later of using Remix and Metamask to be able to deploy FVM. Right? So we want to make it as easy as it is for developers as possible. And we do this in 2 different ways. One is around foreign addressing support. So we've actually also we've had a new system called a F4 addressing scheme within the FVM itself, such that the FVM can recognize foreign addresses and then translate that back to the developers themselves. So they don't actually see the FVM address. They actually just see what their EVM address looks like, for example, and then it translates within the FVM itself. So that's what we mean by foreign addressing support. Of course, there's a lot. I'm oversimplifying it, but that is the main idea behind it. Yep. And the second way we do this is through account abstraction. So what account abstraction means is that your smart contract doesn't begin from an externally owned account, an EOA. It begins instead from just your wallet address. So it makes it much easier, and again, as I talked about, that seamless developer experience. And lastly, we have built-in resource metering. So for gas estimation, that is within the FVM itself. So when you deploy the code, you should be able to get a gas estimation. And now I will run through the model. So this is the model for the FVM to give an idea of where it sits. So I talked about the layer 0, which is the Filecoin storage network. And so you have many different nodes running there. And so every single Filecoin node, that's where an FVM would sit on top of it. So everything I described around here, around what it can do, is within here, within the FVM. And then so with the FVM itself, what we would allow for are two different categories, one which is native actors and one which is foreign actors. Foreign actors is what you are used to, so you can see with like EVM, next time we'll build for Solana, and so on. These are all the foreign runtimes that we want to support, which is what I talked about with these two things. And then this other part would be around native actors. So native actors are when you build it within the FVM itself. We have two subcategories here. One which is built-in system actors. These are built into the FVM hard-coded. These are system actors that will give you many different kinds of functions when you build out your user-defined actors. So user-defined actors are whatever you want to program, and that's where you can build all your different solutions on. Yep. So these two are native within the FVM. So I'll run through the roadmap now to give you a sense of where we were at earlier this year. So everything has been developing really, really quickly. So in July earlier this year, we actually released FVM 2 mainnet, which is the Filecoin mainnet. So yes, FVM is live today. However, it is live only for our built-in system actors, and so it's not something that is programmable by users today. Right? So we've launched the first part of it, and it works for the mainnet. And also, this portion here, you see FIP. FIP is Filecoin Improvement Proposals. It is open to community, so if you're a developer and you want to contribute to how FVM is being built, you can actually write a FIP on our GitHub, and we will respond to it and try to add that into how we built the FVM. Okay, and fast forward to now. Chigum, we are at M2.1 milestone. So this is the FEVM. Right now, we are very, very focused on allowing for seamless EVM deployment to FVM, and we call it the FEVM. So that is the phase that we're focused on. There are many talks that are coming up in content and hackathons. Actually, we have a hackathon this Friday that I will share about. It is just focused on FEVM itself. So right now, all on the FEVM is on testnet. So our testnet is called Wallaby. I will show you in the demo later. So that's what you can use right now. It will be launched, FEVM will be launched to mainnet in February 2023. So that is, so that's Q1 2023. After that, we will move on to M2.2, which is when we will allow for user programmable actors. So that means that developers themselves can then build different smart contracts / actors and launch it onto the mainnet, which will be around mid-year 2023. And then M3, which is later in 2023, the later half of the year, we will be focused on how we can optimize for FVM and also build for other foreign runtimes, which then can include Solana and so on. And then the last part is there is a whole calendar on every single feature that we are going to release weekly. We have this for every single milestone. This is the one for 2.1. So if you are interested as a developer, you can go onto GitHub and you can see every single feature that we're working on week. So now we'll move on to a few ideas for solutions before we go into the demo. So yeah, some really interesting scenarios here that a lot of our community has asked for is around perpetual storage deals. I talked about it a little bit earlier on, but what it's talking about is that how do we enable you want to store a piece of data, but you never want to lose it, right? You want it to stay there forever. So we're right now we're thinking about how we can use FVM, and we're working with partners like Lighthouse, for example, to use FVM and FEVM to automatically renew deals, automatically replicate deals, or repair them if they are spoiled, so that it's not, so anytime you need the file, you should be able to access it with zero downtime. And so that is the goal. So that's a really interesting use case that you can use this for. And this can be for anything, websites, data sets, all the dApps that build on top of your data sets. That's what Perpetual Storage will be able to support. So the other one that's really interesting is around decentralized access control. This one talks about if you have a piece of data and you want to only limit a number of people to be able to access it, or you want to have certain criteria that they can access it from. So if they pay you a certain amount, then they can access the file, but without any of the validators in the storage network to be able to look at your data, that's where the FVM can come in. So decentralized access control, you can set a smart contract on an actor to determine who can view it under what criteria, and for what amount of time, and then you can launch into mainnet, and it should be able to run automatically. Yep. And Medusa is a piece of technology that right now Protocol Labs is working on. It is something that we hope to build on the FVM. And then there are data DAOs, which is a very big use case. I'm sure all of you have heard of data DAOs, very exciting. So let me walk through how the FVM can support data DAOs, which is one of the ways. You can think of many other ways. So for the first piece, you can think about how it can collectively curate data. So you could have an FVM that, if a piece of, you want to set the criteria that when someone uploads an NFT, I want it to automatically go into my data DAO's data set. That's something that you can create. And so you will have a growing data set, and you can govern what goes into the data set itself. And then you can also then govern and monetize access to the data. So you can set a few FVMs that, like I talked about decentralized access controls earlier on. You could use that to govern how people access your data, and you can earn money based off of that. And then for the last part, which is good for members of your data DAO, you can then take the money that you earn from here, and you can put it into a DAO treasury, which then can sponsor retrieval of data for members. So for example, if you have a few, you can encourage member engagement. So the higher rank a member, you can maybe have access to sponsored retrievals of data. So in an NFT, you want to get free NFTs every single month if you engage to a certain amount. And so that can all be programmatized with the FVM. And of course, you can also use an FVM on top of that to automate everything I just talked about. Okay, and then we talk about compute over data. Because earlier we talked, so what the FVM does is to compute over state, which is metadata of your storage, of your stored data. But computing over data itself is a layer 2 solution. So once you use the FVM and you've decided this is the piece of data that we want to download or we want to use, you can then have a layer 2 solution, which is computing the data itself. We have solutions that are being built up for that. But that then gives you a lot of opportunities because that's where your dApps come in. That's when you can have data science, decentralized data science. So these are the kind of visions that we have for what the FVM can enable. And then lastly, so where Filecoin really hopes to be is that we eventually hope to be a substitute in Web3 for what like AWS, for example, can provide, right? So that's server. But to be able to reach that, you need compute, you need programmability, you need scalability. Right now we have programmability with FVM, that's what it will enable. And we are building out compute, which is compute over data. And lastly, we have scalability, which is being built through something called the IPC, interplanetary consensus, that will allow you to scale and spin up different subnets of blockchains as well. So that's another team that's running that, and also that's building on the FVM. So once we have all these three things, we can see how we can then enable web-scale Web3 applications, and so eventually being able to have a substitute or an alternative to what Web2 can provide you today. So I will do a short demo on Remix and Metamask to show you how it can work with FVM. So this is my Metamask, it's a fake account, but Metamask account. You can actually connect it to the Wallaby network. So this is testnet Wallaby Metamask, and I have already taken funds from the faucet on the testnet, and so you have TFIL within your Metamask account. So I've used a simple remix. I've just used a template contract just for a demo. I've taken a simple storage contract and put it in here. And I've actually deployed the storage, so I've connected it to the MetaMask itself. So right now it is connected to Wallaby. And you should be able to program, like we've had developers in the community already build their user contracts on FEVM within here and deploy it to the Wallaby testnet. So that has worked, and I'm just showing you how you can do it yourself. Right, so I've already deployed it, and so what I want to show you is how, for example, you could just do a simple store. And yeah. And then from here, you can confirm your gas. You would then deploy it. And it takes a while. The reason that it takes a while is that for the Wallaby testnet, it's a 30-second epoch. So every single 30 seconds is when a new epoch is formed. So it takes around that time to get the deployment done. Yeah, so you can see it's pending. So I would leave that. So yeah, great. You can see now it has stored the amount over here. And so if I go to retrieve, it will then show 100 over here. So that's just a simple way that you can see that your smart contract can be deployed to the Wallaby testnet. And as of today, we are releasing events and logs on the FVM Wallaby testnet, FVM and Wallaby testnet. So I think within 1 day, 24 hours, you should be able to deploy more complex smart contracts that require emit lines, events, and logs itself. To connect your wallet, a really easy way to do it is you can go on Chainlist. If you search for networks, make sure you turn on testnet on, and then you can easily connect your wallet from here, the Filecoin Wallaby. So if you have your MetaMask, your Coinbase wallet, whichever it is, you can connect it very easily here. And if you have any feedback for wallets, because we just started testing with MetaMask, MetaMask is okay. We are testing now with Ledger, and we're testing with Wallet Connect. If you have feedback for wallet integration, join the Slack and give us the feedback so that we can improve on it. Okay, so some resources for you. We have the FVM hard hat kit. So if you are more comfortable with hard hat, you can always use the starter kit over here. We have also just added in a mock solidity library, Filecoin mock sol. We have a full, so Filecoin mock solidity library will allow you to call to built-in actors to simulate what it will look like during mainnet launch for FEVM. We will have the full library built out in about 10 to 15 days from now, but for now you can actually try it out. And we have a developer forum open, so any feedback, this is where you can go. We also have a lot of explainers, so any new releases that we put out with new features, we will be explaining it on the forum as well. This is where every content goes before it goes onto the docs. So we are still building out the docs, but this is where you get all your information first. And we have a hack coming up, so if you want to try out building, see how your project is like, we have a hack starting this Friday, Friday midnight for Korea. Yeah, it'll be over the weekend. There are quite a lot of prizes. You can check it out. I think it's up to $50,000 in prizes, so you can check it out. Yeah, our whole team will be online helping it out. So yeah, you can meet the team there. And this is our early builders program. So longer than a hackathon, if you want to build out a solution as a business or as a very interested developer to see like every single week when we release a new feature, you want to build on top of that and you want to get feedback for your project, we meet every single week. You can join the program, you just have to apply, I'll take you in, and then yeah, you can work together with the team and help us build out FVM. Yeah, so these are some of the companies that we're working with today. Lastly, Majimak, if you want to join FVM Slack, that's where all the technical discussions happen, and also announcements, releases, anything to do with FVM, it will be on the Slack. So you can join us on the Filecoin Slack and find the FVM channel. We will be there. Yeah, we answer questions like every single day.
프레젠테이션 파일 슬랙의 FVM 채널에 공유해 주시면 감사하겠습니다.
Oh, yes, of course. 당연하지. Yes.
당연합니다.
If anyone has any questions and you want to think about it and send it, FVM Slack, or you can DM me at Twitter. I can reply you on your questions after this. 감사합니다.
네, 감사합니다.
네.